what is it in particular about algebra and linear algebra that you find so fascinating?
Yeah, my love for math really started really early on. Even as a kid in elementary school, I liked manipulating numbers. I'm one of these people that mix numbers with colors, and there's a name for it, and it always escapes me. But that made me the fact that numbers and colors in my mind were combined as a young girl really interested in manipulation of them. It was just a fun game for me to play.
Yeah, that's
And yeah,
synesthesia.
synesthesia, that's it. That's the word.
Yeah.
Yeah. Um, and and I think that really drove my fascination when I was young with math manipulation. To me, there seems to be this other language out there, and that was the language of numbers and the language of colors for me, and I tried to understand it. Um, but as I was growing up and being exposed to more and more math, I started seeing mathematics as this fantastic language. Really, the way I studied English and French and a little bit of German was no different in my mind than the way I studied mathematics. Um, there are all these concepts in mathematics. They're numbers, they're matrices, they're vectors, they're entities that you can manipulate according to certain laws. So it's like words and grammar. You've got concepts and mathematical algebra. How do you there's this thing called multiplication. You can manipulate two numbers by multiplying them. It's it's a rule that opens up, in my mind, at the time anyway, this sort of language or game, if you like, of playing with mathematical entities, and I just found it entirely fascinating. Um, as I was, you know, continuing in my math education, I started realizing that some parts of mathematics were really everywhere. Like I say in my linear algebra talk, linear algebra is at the base of almost everything that we do in computational mathematics. Is at the base of much of data science. Is at the base of all simulation, and so I really wanted to understand those connections. And it was incredible to me that so many different applications that I've worked in also, from airflow to subsurface flow to traffic flow modeling to other aspects of data science that I've worked on, the pterosaur replication, that they all had that common base language of linear algebra. And when I first came to the United States and started studying at Stanford University under an amazing professor called Gene Golub, he used to say this. He said, ultimately, all engineering is linear algebra. And I've become to believe that. So it's like having this universal language for so much in science and engineering, and then being able to translate physics and engineering processes and human processes into that language, just mind-boggling to me. So and then of course you see that I had some natural ability, not a huge amount. I don't think I'm a genius at all, not at all when it comes to mathematics, but I had some innate ability and then worked on improving my skills in that area. And as I was doing that, I saw so many people around me give up on mathematics or saying, we just don't get it. And I started realizing that it has much, much more to do with the way that we were teaching and the way that we were explaining than with people's ability to actually grow to understand this. I mean, most people can learn a new language. You don't see many people say, I just cannot do another language. They may say, I'm not as good at it, or it takes me a long time. But people tend to accept and know that if you apply yourself enough, you can speak okay. You may have a strong accent, like a Dutch accent, but you can make yourself understood. You can read, you can comprehend the spoken word. But with math, there's still so many people who believe that that is really one of those things you just have or you don't have. And I've never believed it. And I've always been on a quest to show this and help people really discover their ability to learn and improve over time in this beautiful language that also opens up so many doors. So, I ended up studying mathematics ultimately because as a teenager, started thinking in high school about what I would like to be. And I was fascinated with weather, so I thought, oh, maybe I should be a weather forecaster. But I was fascinated with bird flight as well, so I thought maybe I should be an ornithologist. And then I was fascinated by the Earth, and so maybe I should be a geophysicist. And then other friends of mine were starting to get interested in finance, and I thought, oh, that sounds pretty fun too. And I was interested in biology, and there were so many different things. And I thought, wait a second, I don't really want to choose. How can I keep doors open to all these areas? And I found this math as this base language of so much of what we do in science and engineering to be the ticket. So I thought, if I study mathematics and then computational mathematics, I can go and work on whatever I like. And when I look back on my career, that's exactly what I've done. But I've gone through so many of those doors, and so it's been fascinating. So clearly, I love it. I think it is fascinating. I think it allows access to so much other work. It's very empowering to scientists and engineers to understand math. And we see a lot of people struggle with this. And I believe a lot of that has to do with some myths about really needing that innate ability. And if you don't have it, just forget about it. So people give up early. And also about teaching that is really not very optimal. So I've enjoyed over time in my career to try to explain concepts in a way that's more intuitive, that explains the usability, the power of the mathematics, and I'm happy if that has resonated with some people. That mathematics gives you wings talk, by the way, that was an interesting story. It was almost an impromptu talk at Stanford. I didn't even realize at the time they were taping it. They were going to put it out on video. I'd almost forgotten about it. It was reunion weekend, homecoming weekend at Stanford, and the football game was starting. Big football game. I was going to go to this football game, but just before the game, I checked my email, and there was this reminder saying, "Hey, Margot, you're supposed to give a lecture for homecoming weekend." This was a homecoming weekend lecture called A Class Without a Quiz. And I almost forgot. And so I went in a little bit unprepared, and I literally winged that talk. So, but then they taped it, and I didn't even realize they taped it. And then my son, I think it was a year later, he was looking for something online for his math class. He was in was it 2000? Yeah, he was in middle school, I think, at the time. And he says, "Mom, we needed to find a video on math, and I found you." And I said, "What video did you find?" And he said, "I found mathematics, and it gives you wings, and you have 250,000 views." I said, "What?" So that was a surprise. So that's an older video. And the responses to that video have also been very interesting.